Hi, Sandeep. I'm so happy to have you with me today. So, for everyone that's there, my name is Michael Gibbs. I'm the founder and CEO of Go Cloud Architects. I am here with my good friend Sandeep, who's one of the best DevOps engineers I know anywhere. And today we're going to do a AWS cloud migration, a lift and shift strategy. So, for those of you that don't know me, I've been working in tech for about 25 years and helping people find their first tech jobs or get promoted in tech for about 20 plus years now. God, it's been so long I can't even remember. And it's something I absolutely love to do. And I train cloud architects. My friend Sandeep here trains DevOps engineers. In fact, don't be surprised if you see a How to Get Your First DevOps program coming from Sandeep and me coming very, very soon with all of Sandeep's expertise in DevOps and all of my expertise in helping people get their first tech jobs, which I've done for networking, Linux, cloud, you name it, I've done it. So we're real excited about that, and that's coming out real soon with me and Sandeep. Today, what we're going to talk about is a cloud migration strategy. Now, if you were to look at the AWS website, they've got 6 versions of this. I mean, rehost, replatform, refactor, re-architect, repurchase, retire, retain. Let's face it, let's really boil it down to what is a cloud migration. You're either doing, for the most part, one of two things. You're either taking things the way they are, virtual machines and containers from the data center, directly to the cloud. 90% plus of all cloud migrations are this. The reason organizations love this lift and shift strategy is as follows. You take a VM in a data center, move a VM to a cloud. Take a container in a data center, move it to the cloud. Here's why this is such a good cloud migration strategy. If you go to the cloud provider and it doesn't work, no big deal. You move your VMs to another cloud provider or back to your data center. There's no cost to refactor your applications. There's no time to refactor your applications. And it gives you the chance to see if the cloud performance is as good as you're getting in the data center and if you can tolerate it. You also get to learn, hey, wait, is this shift from capital expense to operational expenses actually good for my business? On paper, it looks great. But in practicality, when you do these migrations to the cloud, you pay for usage. So if your things are heavily utilized, super heavily utilized, it might be cheaper in the data center. But the cloud allows this agility, scalability, flexibility beyond anything else in the world, which makes it so great for businesses. But you as the cloud architect need to know what is best for the customer given a certain circumstances, a certain time. So lift and shift, which AWS calls rehost, is what we're going to be doing today. Now they have another version of this they call replatform, but that's really basically the same thing, but you modify a thing along the way. So basically, you've got the option to lift and shift. And your other option is to go cloud native. And I know one day I'll do this with Sandeep. He's an expert on these cloud native services. And this is basically, you take the things that you had in the data center and you completely recode them, completely redesign them to go work on the cloud. Now, this has a lot of benefits because now you can go serverless. You stop worrying about, operating systems and storage and IOPS. All that's gone, which is really great. But if the cloud provider raises your rate, you're in trouble because you can't get off now and you spent a lot to go there. If the cloud provider doesn't like something about your business and kicks you out, you're in trouble. So if you're going to go cloud native, you're probably going to do multi-cloud. But again, great options. The cloud native is agile, flexible, scalable, and we love that for other reasons, especially for a greenfield deployment, like a brand new deployment. There's no applications to recode. You got to build your applications in the first place. So there's strengths and weaknesses of each one. We're going to do lift and shift today. Now, I want to let Sandeep introduce himself. He is a phenomenal DevOps engineer, an incredible cloud engineer. So what we do is I'll talk about it and design it because I'm an architect and we design, and then we have the engineers build it. So Sandeep is actually going to build this for us live, and I'm super excited. And this way you can see the interaction of the cloud architect versus cloud engineer. You get to do things from the DevOps perspective, engineering perspective. We're going to do things, and we welcome questions. If you have questions, we want to answer them. So it's a turn to you, Sandeep.
Yeah. So migration is the so right now you can see the day by day passing, and more people who are running the application on their local data centers or say on premises, they are moving to cloud, and this is the same reason why the demand of the cloud also increased exponentially. Now, you might see another thing there. There is not enough resources there to support the migration, isn't it? And that's why there is like everyone want to migrate, but they look for the resources and then hire people, and that is the reason the migration is one of the, like, having migration skill is one of the most in demand skill set. but often people don't know how to do migration. They like move it everything, like having more servers is important, like do migration as soon as possible. But they forgot that when doing the migration, there are a lot of dependencies. Okay, and there could be like data dependency. The dependencies could be related to the binaries, whatever it needed to actually run the application. Dependencies could be according to the environment and how to pass the environment variables. There are a lot of different requirements are there, and people miss it and find it out in trouble when they actually try to move. So they have to plan it well. Why we need our cloud architects? So they can plan it well, and the execution has to be done by the DevOps engineer. So this is what is everyone has to understand, and they have to run it really well so they can perform their jobs well. Yeah, over to you.
I think that's absolutely a perfect description, Sandeep. So while it takes people like me to design it and then convince the customers they need it, if nobody builds it, well, we don't really have anything. So that's where this comes into play. The other part of this is what Sandeep mentioned, which is super, super important. He mentioned that, if you don't have the right information, you can't do the migration correctly. So I want to let people know what these migrations actually look like. For a large scale migration, I might have 10 cloud engineers on site, 20 engineers, 30 engineers. I've done migrations that have had 50 cloud engineers or 50 engineers that have spent 6 months at the customer mapping out data flows, mapping out storage, mapping out networking, mapping out everything long before they can even think about migrating things. So it takes both. I mean, it takes people like me that really get the business goals. So I want you to understand the true architecture. We're trying to solve a problem. We're trying to solve the business. So we architects are at that business level. What business challenges are you trying to solve? And that's what we do. Now, by comparison, it doesn't matter how theoretical we are with the business and how nice and pretty our architectures look and how well we describe and present them. They've got to be built. And we architects and engineers have different skill sets, and we'll answer all the questions that come in. Basically, we'll do the demo, and then after that, we'll talk about how to get whatever job you want. We love coaching this, so we're thrilled to do it. Chris from my team is going to aggregate questions that are right for me will get sent to me. Questions that are sent to Sandeep will be sent to Sandeep. And I promise every question will get answered. So in this case, what we're going to do is we're going to have a little fun here. Sandeep has pre-created a data center application, and it's running happily in a data center in containers, which is the modern microservice way to do it.
Right.
And by comparison, he's going to take that application, he's going to show everybody what the application is and talk about it, and then he's going to do an AWS cloud migration, and he's going to move it to the AWS cloud, and he's going to show everybody how it works. So I love when we get to have the architects and the engineers work together. This is reality, everyone. This is how we work.
Yeah.
Architects design, engineers build, and it's always going to be that way, which is why I'm so strong about telling people, if you want to be an architect, don't study sysops. If you want to be an architect, don't study DevOps. I think DevOps is amazing. I love DevOps. I'm not a coder, so I'm not a DevOps person, but I think it's great. So it's all a matter of train for the job you want. So Sandeep, I'm really excited to have you show people how to do the migration and really show them some strong cloud engineering skills.
Indeed, I'm excited too. So I'll be showing them how normally application run in local system, how to containerize that, and then how to move to AWS cloud, how to operate the application and configure the microservice. I'll be showing it all. But I think Mike, you can just explain that there are 6R. It's a bit deep. Like, what are the differences? Because people will get confused between actually the question what are the rehosting, what are the other strategies? A bit details, and then we'll cover the first one. So
I think that sounds absolutely terrific.
Yeah.
So, let's talk about what those 6Rs really are. The first one is something called rehost. And basically what we're doing here is we're basically moving the applications and everything we have with literally no changes, literally none. So we've got a virtual machine in the data center. Say it's on VMware ESXi, that's a web server. We've got a virtual machine that's an app server. We've got virtual machines that are databases. We take those virtual machines and literally all we do is make a machine image out of them because they're typically virtualized anyway. So we make an image of them and push them to the cloud. And that's it. We just launch them as new instances on the cloud. This is fantastic. Just to let you know, most of it, what everybody does is this. I love this. You've got the most flexibility on the cloud, off the cloud. That's called rehost or lift and shift. So this is your typical lift and shift cloud migration. most common. Excellent, 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 because there's no experimentation. You just know it's going to work. What do I mean by it's going to work? If it's working in your data center, and what is the data center? It's a room filled with networking gear, meaning routers and switches, servers, load balancers, firewalls, VPN concentrators, DNS servers. Wait, you move it to the cloud. What's a cloud? Hey, wait, a virtualized data center and a virtualized network. So it's the same thing. You're just taking it and you're just literally moving it to another location. So I love this. It's called rehost. Now, replatform. It's kind of almost the same, but not exactly. So when you're going to the cloud in a replatform environment, you're doing mostly a lift and shift, but you're tuning some things on the way to make them better for the cloud. And, I kind of like this. So let's say you've got a 3-tier web app. You got your website on a virtual machine, you keep it on a virtual machine. You got your app tier on a virtual machine, you keep it on a virtual machine. But then you say, hey, wait, this database scaling thing is kind of annoying. I've got all these replicas, and I've got all this caching, and I've got all the queuing, and I'm trying to partition things. That doesn't scale as well as I need it to. So this is where you could say, hey, wait, I need a super scalable database like Cassandra. I could put a Cassandra on EC2 instances, or I can use a managed service like Keyspaces. So this is called replatform. So rehost is basically move it identically as it is. Replatform is basically move most of it the way it is, and then tune it to take advantage of some services. Again, love this option. Like, for example, S3, great serverless environment, easy to get your stuff on and easy to get your stuff off. So we get the benefits of the lift and shift and flexibility, but the benefit of the cloud native services, and I strongly encourage this. Now, this is where it starts to get a little more expensive. When we start talking about refactor, re-architect. Now, I got to say this, the cloud offers some things that are truly amazing. The ability to scale without thinking about it, the ability to almost forget about patching your systems. This serverless environment is truly amazing. I love it. Now, I'm an architect though, so I evaluate the business, legal, and technical things of everything. There's a strength and a weakness. There's nothing that comes free. So while you do this and you redesign your applications to run into serverless and use great things like DynamoDB for super scalable databases and other types of serverless environments, remember, you have to refactor your applications. This could be massively expensive, or it could be nothing. If a company's starting out and you go this way, wow, this is perfect. This could be a $10 million or $20 million or $100 million project based upon the sophistication of the organization's code and how long it took to build them. So when you're doing this kind of environment where you're refactor, re-architecting, it could be truly transformational for the business. It's also high risk because if it doesn't work, you're in trouble. The other side of this is if you get to the cloud provider and you run into a problem with your cloud provider, you are in trouble. You got to recode everything, rebuild everything. You go somewhere, your rates go up 30%. Can you afford it? Well, that is the danger with this because it's not going to be so easy if you rehost your things and put them on the Microsoft cloud or the Google cloud or the AWS cloud, where you basically redesign them, re-architect them. And when you want to leave, you can't because then you got to redesign them to go back to the data center. So strength is unlimited scalability, which is wonderful. Strength is extreme agility, which again is wonderful. Strength is new features, which may or may not even be cheaper. Again, wonderful. Downside is you can't get off the cloud, not easily. So keep that in mind when you're advising clients as a cloud architect. All good options. Now, the next kind of concept that they talk about is something called repurchase. And realistically speaking, this is basically moving from like a perpetual license, like you get a license in something, to a software as a service model. So this is an environment where you're basically just purchasing a cloud-based managed app. And again, this is kind of great. I'm using a couple of cloud-based managed apps right now. I'm using a cloud-based managed app to stream things. I use another cloud-based managed app to host my things. This is a great environment. Hospitals are now using cloud-based electronic health records. Love it. It's really great. Now, the next thing they talk about is something called retiring. So there's a point where you actually look at your systems and you try and modernize it, and you kind of look and say, wait, what do I even have? I work with organizations that still have mainframes. I'm not joking. They still have mainframes. Big global banks are running on mainframes in the middle of all these highly sophisticated systems, 15,000 servers with 128 cores and 15 terabyte and like 4+ terabytes of RAM. Systems that have 8 Quadro A8000 GPUs in them, or RTX 8000s, hundreds of them, and yet still you'll find some mainframe in the middle of nowhere. So, at some point you can migrate your things to more modern things, and it reduces your cost by not supporting legacy applications, and that's one of the ones. Now, the last thing that they talk about is something called retain. And this is where an organization keeps the applications that are critical for business, but that require major refactoring before they can be migrated. So basically, this is something that you might do at a later time. Again, a really good option. So there are basically the 6 options for cloud migration. So Sandeep, you want to show one of the versions, which is my favorite, because I'm an old network and data center guy, and I love those environments so much. Sandeep?
Yeah, I can hear you.
Okay.
Now I can hear you.
Over to you.
Okay. So thanks, Mike, for explaining all that, because that was necessary to to what I'm going to do now. Otherwise, people will not understand what I'm doing.
Completely.
So yes, so people have to understand that if you want to move one application from on-premise to the cloud, there are many ways, but the failure, again, the dependencies part. So, and having containerization, or you can say containerize the application with all the dependencies that encapsulate the application, and then moving to the main cloud, it will be much easier. So whatever migration work I have did,
Okay, we're having a momentarily technical difficulty. When I describe to my clients the difference between a private line or a direct connection versus VPNs, and I say the internet traffic is only best effort, meaning there's no guarantee, for example, that your traffic is delivered. Where with a direct connection, realistically speaking, your bandwidth and latency is guaranteed. So we're going to wait for Sandeep to get back online. These things happen when you're dealing with technology. And in the meantime, until Sandeep comes back, I'm going to start answering some questions. So let's look at some questions that I can actually see here. So the first question I see, and we're going to answer the career ones too, because that's really where we're world. Okay, so the first question while we wait for Sandeep is XB Lama. Hi, Mike. I'm thinking of the following certifications before applying for a cloud architect role. Would these be good, or would you recommend something else? So, realistically speaking, this is not for a cloud architect role. You're going to need a couple things. If you have the Red Hat, I don't know your background, XB LMA. So if you told me your background, that could give me more information. Having said that, while we wait for Sandeep to come back on, XB LMA, here's what I'll say. If you wanted to be an architect, it's not just certifications. In fact, I'd say the certifications are 10% of the process. The minimum level of certifications we see are professional ones. So the Certified Solution Architect Professional is a baseline intro level to cloud computing. I know people think it's complicated, but I got to tell you, after being an architect forever, that's like an intro level of the Certified Solutions Architect Professional. Now, after that, we need to get you some knowledge of the network and the data center. So the CCNA is a good thing to go there, go along with it.
Okay, that's finally I joined.
Basic knowledge of the data center. Wonderful, Sandeep. I'm so happy you're here.
I don't know what's happening.
Question, and we're going to go back to you.
Sure.
So
definitely.
XBLMA. So the CCNA is good. The AWS Certified Solution Architect Professional is fantastic. Love it. Maybe the Red Hat Certified Engineer, or maybe the Red Hat Certified Architect would be a really good one. What you're trying to do, I don't know what your background is, you're trying to build a case to show that you know the network and the data center, because that's the cloud. So with that, that's a percentage of it. Again, architects are communication jobs, they're presentation jobs. So you got to train emotional intelligence, executive presence, system design, how the parts and things work together, be able to do ROI modeling for your customer, be able to present, be able to write like an executive. 2 executives know what the CEO wants, CIO, CTO. So these are very, very, very different skill sets than those that are covered in the certification. So that's the process. I will talk about how to become a cloud architect later, because it sounds like people desire that, and that's okay. In fact, Chris will put the link. I am running a free How to Get Your First Cloud Architect Job webinar at 12 p.m. where I will answer all these questions live, and you can even ask me questions live on Zoom. So we'll do that. So XBLMA, I hope I answered your question while we waited for Sandeep, but Sandeep is back. So I want to remind you, we architects do the high level design, and we talk about the principles of the how and the why. And then XBLMA, the architects are going to do it. So Sandeep's back, and he's a cloud engineer, so he's going to do the things designed by the architects. So Sandeep, back to you.
Yes. So can you add this? Yeah. Thank you, Mike. So you can see, like we have like to move application, you need the application first. So it's a very simple application. If you look at it, it's simple Node.js application where you're utilizing simple models. So you can see the dependencies fine here. So you're utilizing mainly the Express.js, which is a server-side framework to run the APIs. And if we go to index.js, it's simple. So in the root, we are saying okay. And suppose it's an example of microservice where the service is the global path and this is the service path, that is a Node.js app service. And we have a status path to check that. You can see it's a health check to make sure the application running fine or not. Okay. And this is the application. Now let me run this application and show you like what is the expected output of the application. So to run the Node.js application, you have to do node and then the main entry point file, which is index.js. And let me open that and change the path. So you can see here, it's simple saying okay. And if we come to this path, say this one, it's saying this is simple response from node service one Node.js. Now this is our simple application. Now to containerize it, we need some kind of container service. For here, we are utilizing Docker. So let's look at the, to containerize the application and to use Docker, you first need to install this Docker, either desktop or either binary, to make sure that you install a Docker machine. And to install that, simply go to Google and find the Docker installation. Okay, simply go to the first link and see, you can see Docker engine installation. And based on whatever the platform you are, could be Mac OS, could be Windows, or could be the server-side platform, whatever it is, you can choose your target platform, install the Docker for your machine, whatever it is. And then once this install and started, you can start making the image. So to move this application, now this is application, it's in the local machine, could be in data centers or on premise. Now just think about that. And now you want to move the application from there to the cloud. Now to do that, we have to first, with all this, so these are all dependencies inside this folder, which is called node modules. So node modules have all the dependencies. And in the index.js, we have the main code. So you have to encapsulate the main JavaScript files as well as the all dependencies. Okay. And of course, the runtime environment so that we can run the Node.js application, like how I did run the Node index.js. And to do that, for the Docker, we have a file called Docker file. And it's a very simple one. So first, we are pulling the base image. So Docker, either you can create your own like from scratch, or suppose there is some existing image available, you can just extend that image to suit your requirements. Okay, so here we are utilizing Node.js version 14. You can see this is the base image and this is the tag. So we are using Node.js tag 14, which is the Node.js version 14. And then inside always remember these are the keywords. So from work directory, copy, run, and I will explain what these things does. Okay, and we have the work directory. So it creates a directory which is our main like default path. So if we do SSH into the running container, this will be our default running path. And so this is user src app. And after we define the work directory, we are copying the package.json, because package.json contains all the dependencies. You can see this package.json. It contains all the dependencies needed to run the application. So that is there. And then after the packages are copied, we are running the npm install, because to install the packages, you have to run the npm install command. And this run command actually run any Linux command or whatever the platform support, that command. Okay, so platform in the sense that this image, what is the base OS is based on that. So there we are running the run npm install command, and then after the packages are installed, then we are copying all the source codes to the image. Okay, and then you're exposing the what is our target port, that is port 3000, because any application, if it's a web, it has to run on a port, and we are utilizing port 3000. Again, just to confirm, you make sure that whatever port your application actually running, that has to be the port that you expose. And after all these things are done, you're just you're entering the command line and saying that running, like it will continuously run, and if it stop, that means the Docker container also stop. So this is the command node index.js, just like I did run the application in the local. So you can see it's a complete, or you can say simple example of lift and shift. How you're running in the local, we're going to exactly run the same using the container, isn't it? And you can see it here. So now to containerize the application, we have to simply run doc. Now, before even containerizing, you have to first think about where are you going to store the image. Now you can store image anywhere in the AWS, Azure, GCP. Everyone have their own Docker registry. Now, importantly, Docker also have a Docker Hub where you can store for free, or if you want it private, you can have to just pay for that. For our use case, since you are going to host, or you can say like use the application inside AWS, so it will be utilizing AWS own Docker registry, which is ECR, so Elastic Container Registry. This is the one. Let it load.
Now, Sandeep, let's explain
Yeah.
what Elastic Container Registry is for a minute.
Uh-huh.
So,
Sure.
there's two ways you could manage your containers. There's the traditional way you do it in a data center, where you set this up on a server and it's your own container management platform, and it works great. Or if you go to the cloud and you're looking for something more cloud native, AWS has a serverless environment that will basically orchestrate your containers. So instead of you building your container orchestration platform on, say, a virtual machine like an EC2 instance, or an Azure virtual machine, or an instance on Google Compute Engine, we're just using a cloud managed service for this, and it's nice and it's simple and it's elegant. So Sandeep, let's go back to you on that one.
Sure. Thank you, Mike. So yeah, so Elastic Container, you can see from the definition itself. Amazon Elastic Container Registry is fully managed container registry that make it easy to store, manage, share, deploy your container images and artifact anywhere. So ultimately, it's just simply meaning you can store your images inside Elastic Container Registry, and that's it. And you do suppose you just created something. You are not paying for creating it. You are paying for storing the data. So let me show you the example. So first, let's create the repository. Say, so if you do public, I think it's free. And if you want to create a private, for that only you have to pay. Okay. And let's say it's the Node app demo. Okay. I think we already have some project with the same name. So say Go Cloud Architect Node demo. Okay. Now go down, and you can have all these options. If you want, you can enable. For us, just for the demo purpose, I'm just scaling simply and click on create repository. So this is the one. See, this is I worked with so many applications. So this is the one. So Go Cloud Architect Node demo, and you can see nothing. Now, if you just created it and you didn't store anything, they're not paying anything. And if it's of course private, if it's private and you store the images based on the size of the images, you have to pay. Say 1 GB, 2 GB. So based on the size of the image you store, that only you have to pay. I'll show you in details. Let's first push the image. So if you want to push the image, just simply click on view push command. If you don't know anything about like how to do and all, you have very simple instruction. Follow the same, and that's all. Yeah, for that you need to have at least the AWS CLI installed. How do you install AWS CLI? Go to Google and search for AWS CLI installation, and then click on the first link. Let it load, and you have an option between selecting CLI version 1 and 2. I will definitely say yes, go with the 2 because that's the latest and more stable. So go there, and you can see you have to select which is your platform. Are you going to post the image from like Mac OS, Windows, Linux, whatever you want to, wherever you want to run your AWS CLI. Based on that, you should get the instruction to install, and if you simply follow that, then it will be, that's all. So you can install and keep using it. Of course, that for that you need access. So you can see here ECA, AWS ECL login and all that require the access, and to do that you have to run AWS configure, and it will ask you for the that security key and the secret. What you can generate from, show you from where you can generate that. You simply go to AWS console. If you like log in, you will see the screen, and there look for the IAM. You can see it here. Reload, And then you can see this users. Reload first. Okay, users, and then create a user for your local machine. So let's say I have a MacBook, right? So this is the new MacBook. So I will say MacBook 2 since I already had one. Okay, and let's say I need only programming access from my local. So of course I'll only go for that. Next permission. So it's based on what are the access you need. Suppose just for the ECR if you want, then you can say here attach existing policies directly, and there look for the registry. You can see Amazon EC2 container registry full access, or maybe power user based on the access they want to limit, and then go next tags, whatever tags you want to give, go to next and click on the create user, and then you will get the key ID and the secret. If you use that to like after running this command, it will ask you for that. If you set up, that's all. So I already have everything, so I'll be not doing the setup. I'll be simply following the instruction from here, and it will work for me. So let's do that. First, you are logging into ECR. You can see AWS ECR get login password, and then you are piping like attaching, like piping means the carry forwarding the result to the next one, and then you can see Docker username standard input. This is the one, and you can see the result is login succeeded. Then you see it's option for Docker build -t, then or you can see dash t. D means the tagging, and then you can see Go Cloud Architect demo. Which if you don't give any tag, that means it's the latest image. Okay, so let's run that. Make sure where you're running, it's your root folder where you have this Docker file. Otherwise, the build will not run. Okay, so okay, Mike, you want to say something?
Yes, I can see this, but actually, here's one thing that I really would like to say about what Sandeep's doing here, and I deeply, deeply, deeply respect it. So, reading 5 minutes of documentation can save you 10 hours of troubleshooting. So, even though I know how to build it, Sandeep knows how to build this, we both know the commands. We're both senior enough to know, wait, each time we deploy something, go to the manufacturer documentation. They could have updated a package, it could have changed everything. So, instead of just wasting our time, we're going to go to the most recent documentation, whether it's Docker's documentation, Kubernetes, AWS, and we do this every time. The knowledge isn't what needs to be done. They're pasting the commands in, that's easy. The engineers like Sandeep have a lot of knowledge of what's going on. Knowing the name of the service and how to configure it really doesn't help anybody with anything. It's the knowing what you're doing. So that level of expertise, I hope it's obvious to everyone. This is not someone that just took an exam, memorized questions and answers. He knows what's going on in the systems, and that's how he can do this. And because of that, he's still smart enough to say, wait, I must check the documentation. Because most of the problems I've worked with and I've solved for the last 25 years were when people had just decided they were going to go configure things and they missed a subtle thing that changed in a version of an operating system or a package. So great job, Sandeep. Just want to point that out.
Thank you. Because you see, we cannot remember all the commands. To be honest, I know all the commands. If I look at it, I will understand what it's doing. But
one thing,
what is not possible?
One thing I would ask, is it possible to maybe do a command plus to increase the size of the windows or the text so other people can see it a little better?
Sure. I think this window, right?
Yeah, one of the people had said it's hard to see. Oh, that's much better. As big as you can make it without losing things.
Sure, no problem.
Great job.
So I will, thank you, Mike. And I would suggest everyone to if any platform giving some documentation, helping out doing something, of course use that. I mean, Confluence is good, but sometimes if you miss any production system, it might be a disaster. So we don't want that. We want, take more help, make sure that what you're doing is stable and is fast. So, and following this instruction, now it's not like you have to always follow this. If you want some customization, of course you are free to do. But if you're new, you must follow the documentation, and you get used to it, then do the experimentation. That should be your way to go forward. Okay. So now that we have, build the image, I think just hide this one. Okay. So this is the image we have here. I think you can see it. So we have built the image, and if you do Docker images, okay, I will see the Go Cloud Architect demo, the latest image, and we just created 2 minutes ago. So that's here. Now, suppose that is done, we have to, after the build change completes, tag your image with the remote image. Now, what is the remote image? This is the remote image, okay, that you are supposed to push. And to do that, just copy this command, and I will explain the command so you guys. Let's clear the screen. You can see Docker image. Now this is the local image that we have generated and is right now inside my local computer. Could be your local data center or could be your private computer. Okay. Now from there we are tagging. Okay, with the remote. So what is remote? This is my account ID. This is saying the Docker repository link, which ultimately docker.ecr, then dot the region name. You can see it here, then the Amazon AWS.com/ the repository name, and this is the latest tag. If we don't give any name, it will assume it's the latest one. Always remember that. Okay, and if we do that, tagging is done. You will not show any output, so don't get confused there. And after that is done, just simply run this command. See docker push, then this command, and this image will get pushed to the main repository that is in the AWS. Okay, so that's it, and it will get pushed. You can see it's preparing, and it's all pushing. So there are different layers in Docker. The more you add this kind of commands, the more the layer will create, and that will get pushed when you do the Docker pushing. So all changes, any new change I make, it will be another layer of change. Okay. So let's wait for the changes to be pushed. And I think it's very fast, so it will be pushed within a few minutes only. Mike, are you saying something?
No, I was actually watching. I'm loving the way you're doing this. One of the people had asked, what's the most practical common of migration? And for the most part, 90% is lift and shift, which is exactly what we're doing right now. Those other ones have their strengths and weaknesses, as we described in a high level, but this is the most common migration to the cloud. Just take what we have and move it over there. We're basically going from our physical data centers to a virtual data center, which is the cloud.
Right. Because what happens with you more next level you go, there is refactor and all that. It just like so much time and cost consuming. The client don't want that. They want first thing first, move to cloud, then you develop. So they want the business to be on the cloud first, and then you do the refactoring or whatever thing you want. Okay, that's what they want.
Yeah, they want to make sure the cloud's good for their business. The concept of CapEx to OpEx, people talk about how great this is. That could be the worst thing in the world, or it could be the best thing in the world based on the business. So this is a great place for an organization to test, see if they're successful in the cloud, run a hybrid cloud. If it works, move more and more over. If it doesn't work, go back to the data center. So that's why everybody loves this lift and shift. And it feels like 90% of the migrations are those.
Exactly. So that's what it is now. See, I have just pushed the image here, all pushed. And if you just simply refresh it, just clicking on that icon, you can see that image is the latest tag. And when you pushed it, what is the size? And remember, this size is what you're paying for. So if you before using any service, okay, go to Google and search for AWS ECR price. Anything, just anything, you can go here and you can see the pricing here. See, storage, and it will give you per. See, you can this option per GB cost. Transfer in, the transfer out. This is the data transfer one. Let's generate history. I think pricing. Yeah. See, you have to pay 0.10 per GB per month. This is the one. Okay. Oh no, I think they're public also you have to pay. So either private or public you have to pay. Okay. So this is very important. Okay. Okay. See, now we have our image ready, and we can just now easily run it. So we'll be utilizing AWS ECS to run this application. So let me, and Mike, you want to explain about what is ECS?
So when we're talking about an Elastic Container Service, realistically speaking, it's the orchestration. So when we deal with Kubernetes, we've got a cluster management system. We need something to manage where the containers actually are. So either we build this on a server, like we always did, or we say, wait, this Amazon's got this managed service. It's nice, it's simple and elegant. Let me then just use this to service to manage the cluster. And then after that, I'm going to figure out where I'm going to host it. And I've got two options. I can host it on an EC2 instance, just like we did in the data center, because an EC2 instance is just a virtual machine. So we can host, this is the orchestration for the containers. And then so basically, look at orchestration as something called a control plane. So when we talk in architecture, we talk about control planes and data planes. The control planes are things like routing protocols that basically determine the best path to the destination. The control plane is the management of your containers. The control plane is that thin layer of software that the organizations use when you build an OpenStack cloud or a Nutanix cloud or even the AWS cloud. that manages all the databases, and it manages, where your, what do you call it, where your compute is and where your storage is. So he's working with ECS, which is the control plane or the controlling factor for the what do you call it, the containers. And then after that, we're going to determine where we put it. We can either host it in serverless, which is called Fargate, or do it on an EC2 instance. But thank you, Sandeep. That's exactly what we're dealing with ECS.
Exactly. So ECS, we can, we have Kubernetes and all, but small businesses have small resources, and Kubernetes, if they want to have dedicated resource, may be costly for them. So for them, it's de facto, let's go with something more easier, and we have need the less resources to handle that. So that's one of the greatest reason why people push for the ECS. Of course, the Docker also, the Kubernetes also, you run the Docker image, and here also you run the Docker image only. So let's first create the cluster to run the application. As here you can see, that's very important here. You can just run networking only. So networking only in the sense that you can run the Fargate, that is serverless. And here, Mike already talked about the serverless. So if you want to run in a serverless way, you want some time it to be done when there is requirement, if otherwise no requirement, just shut it down. So that's way. And if you want to be constantly running, so you need to have EC2 instances for that. That is EC2 Linux networking. And suppose you have a Windows requirement for any application running, then you can go with the EC2 Windows plus networking. Okay. Since our use case we will be using Linux, so we'll go with the second option, and we'll do next step. And you can see they're asking for the cluster name. So let's say sample cluster. You can say sample cluster. And you can see on demand and spot. Now on demand are we are paying pay as you go model. If you're using, you're paying. If you're not using, you're not paying. Spot is a bit different. Spot is if there is unused resources by AWS lying there, they are giving it for a discount. Use it because you're not utilizing that. But whenever Amazon need it, they will pull it from you, and you can't do anything. They'll terminate for you. Okay, and they will just assign that resource to other people, whoever are willing to pay for that. So if you or your application is okay to go down sometime, then go for Spot. But if it's very crucial, important, go for the on-demand instances. Now here the instance type for our application, we'll go with the, let's say, T3. We'll go with the T3 small. Okay. Now T3 small is a very low resource. I think 2 CPU, and always, if you have any confusion, I think it's a great thing to show. Go to Google, and then go to AWS cost calculator, because these are the skill actually required. This you just don't go in AWS or any cloud and create the resources. You have to first estimate the cost, then get approval of it, and then you define. Okay, search for the EC2.
Absolutely. So while you're discussing that, Sandeep, I'm just going to mention this. At the architect level, we meet with the clients. We're looking at their current systems. Then we're basically going to say, okay, what is the future state in the cloud? And our engineering team is going to look up the cost. And then we're going to build a business case around it to show the customer that the ROI, meaning if you invest $1 million in this, you should get $2 million in return. If, for example, if they invest $1 million and they get 500,000 back, it's a bad investment. So you're going to have to do the cost calculations first, and it might take an entire team of people to do this if it's a big deployment. And only then, after you know the costs, you can compare them with the data center costs, and then evaluate, what is the benefit of flexibility, scalability, and build a business case around that. Because this just doesn't happen where you just say, hey, the cloud's cheaper, let's go there. I love the cloud, and I do love the cloud, but we can't just say go there just because we've heard and read in a book or a blog that it's cheaper. So thank you for pointing this out, Sandeep.
And actually, people have to understand the cloud can be costly if you misconfigure it. If you just I have seen bill like 1 billion, 2 million, even $10 million bill because one junior did something wrong. Okay, right. And there was no control. Then after the things happen, they file the complaint with AWS or any other cloud service. They leave it off and they hire me, Sandeep. I don't want this to be happen any time in my life. Do whatever you can. Then I come as a DevOps engineer. I set the rules. I set the automation there. If someone doing something, I set the organization and everything. I do set up and everything in have a strict policy there. Log checking, the cloud logging, everything. And if something going bad, if there is some email notification, all this complexity coming because of this kind of incident. So of course, make sure. Yeah, no, sorry.
It's so important that I actually want to bring this up. So when you look at about the top 10 things that employers actually care about when they hire a new employee, and we talked about why these entry-level jobs have gone, and there's a video for that. Chris from my team will post that, and what you can do instead to get better jobs, because you don't have to take an entry-level job, you can get a better job. But one of the things that employers care about is, are you safe? Specifically speaking, do you know what you know, and do you know what you don't know? And if you don't know, can you find the answers to things quickly? That level of safety to avoid these 5 million, 10 million, $100 billion, $100 million, or $1 billion mistakes or destroying a company, that matters so much. So like Sandeep said, look it up, research it, know what you know and know what you don't know, and then you'll be solid. Thanks, Sandeep.
Right, and I can see all the calculation, everything is there. So any doubt, any configuration you want to do, like I want to run say 2 instances, just example. See, and this is giving my the expense for 2 instances, and I think it's fine. I can pay for that, and if I pay for that, I can simply run here. I can say instead of 2 instances, in 1 instance I want to run 2 instances because I know the consequences of what I'm doing. So of course, before doing anything, know what are the consequences, what is the cost, what will be the cost of like running the system, or the security cost, whatever the cost you have to calculate beforehand, and then only getting approval from the upper whoever the CTO or founder, then only start. Don't just start by yourself. That's a bad thing, and something bad happen, your job is a risk. So make sure you understand that. Okay. Now, once you're done with here and all looks good, you can just go ahead and see the having a key pair is like if you want to like log in into the system, which I don't really recommend because of course that's open a security hole. But again, if you're managing the container and all, like you have all the controls for the basic element level, then you should not do login in the system because you want to go for the cloud native. Not you're not going to depend on the system, right? So it's optional if you want it. And the networking part is very important. Now if you don't know networking, which is also fine for like getting started and all, but if you want to advance your career to a next level, and if you want to have an in-depth application hosting knowledge, I definitely suggest go for the VPC, because having VPC knowledge is so important if you are customizing the solution, if you want to do performance upgrade, or if you want to have a very complicated application architecture. Normal VPC knowledge is not enough. You have to go in depth.
You
And
have
I
to go
think Mike is there.
in such depth. Now, I'm one of the original Cisco certified internet experts, and I got to tell you, when I look at the AWS Advanced Networking course and curriculum, to me, it's like an intro to junior level networking. The reason I say this is there's so much knowledge in networking, and everybody needs some good skills there. If the network doesn't work, nothing works. Now, I'm going to say in my 25 years, the biggest problem I've ever had was when the systems people, the Linux people decided to do the networking. And look, these are smart people, incredibly smart people. It took me 75,000 pages of reading just to pass my CCIE. And at 75,000 pages of reading, do you know what I realized I knew? So little. And 10,000 hours later of just BGP, and I went, wow, after 10,000 hours and 75,000 pages of reading, I'm now knowing BGP. Now let me learn the rest of networking. So networking knowledge is so critical. So we do a lot of free networking training, and for that reason, Sandeep, I'm grateful you're doing such a great explanations here.
Thank you, Mike. So yeah, so networking is very important. Do go in depth if you want to upgrade in your career, like better position if you want, of course. So yeah, so if you don't have any that much idea not to do, I will suggest go with the new VPC because you don't want any conflict. Suppose you don't want this cluster anymore, you can simply delete it. And while deleting the cluster, the VPC will also get deleted. Okay. So again, go down and see security group. If you want to allow access to any particular port from which resource, or suppose from everyone, go with the this one like 0.0.0/0. Okay. Go down and container instance IAM role. You can simply, if you don't have any, you can create. Otherwise, if you don't need, you can select it. Like most of the cases, if you want any say S3 or any other resource that this cluster instance will have the access, you can add it here. Okay. And this is very good one. So CloudWatch container insight. So how much CPU, how much RAM, all that, very inside of the data. You can achieve it if you enable the container insights. Okay. So let's click on create. And we'll take time. And I think Mike says some noise, so you can explain if anyone have any questions, please cover that.
Yeah, sounds good. That's part of life. In life, there's just noise in certain places. So while we're waiting for the noise to die down, if anybody has any questions, I'll answer some questions, and that noise will die down. And then after the noise dies down, Sandeep will basically go to the next thing. So Chris from my team, I know you've been collecting questions, so can you give me some questions? I'll answer some questions, and then as soon as it gets a little quiet at Sandeep's house, or wherever his office is. What will happen is he'll come back in. So XBLMA, what is the point of a lift and shift approach? How does it benefit if you move the VM to Azure? Can you still keep the VM in EXI? I mean, in replication. Really great question. So I want you to really understand what the cloud is. It's just a network and a data center that's been virtualized. So 90% of everything is just taking it from the data center to the cloud. So what's the benefit? Here's the benefit. When you go to the cloud, you don't need as many people. Now, I'm not going to say that's a benefit. I don't like things that put people out of work. But when you build a data center, you need a bunch of CCIEs like me to really make sure it's available. You don't need that in the cloud. In the data center, you need more people to do things. In the cloud, you can automate these things. You can automate some things in the data center, but basically the reason you're going to the cloud is it simplifies the management. You no longer have to deal with the space, the power, the cooling, which is extraordinary. The real estate to house these things. You're not buying, $50 million of servers and $20 million in networking gear, and you're not buying wide area network connections. So for example, XBLMA, I've worked with organizations that have 40,000 remote locations. That means 40,000 routers, 40,000 WAN connections, meaning private lines or direct connections, plus VPNs. It means 50, 60,000 subnets. Whereas with the cloud, you can just do things like VPC peering, you can leverage the cloud. So people go to the cloud to reduce the complexity. To do this in the data center requires a lot of smart, highly capable people. To do this on the cloud is 80% easier. So in the data center, we do things. In the cloud, it's so much easier. So the reason people are going to the cloud, 90% of it is just to not need as many people and simplify the management. For example, you don't have to launch the server. You don't have to do this. You don't have to find the server resources. Now there's a global part shortage. So even with the VMware and ESXi environment, I need a server. I got to go call somebody, Dell or HP or Lenovo or whomever. They make the server for me. It gets to me 6 weeks later. Then after, or more now in today's world, then it goes there. I install my hypervisors. I lost 6 weeks on the cloud. Click, 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 done. So that's why people are moving these things to the cloud. They're not changing anything. The network in the data center of 30 years ago is the cloud today. I mean, I really want to make this clear. 3 days ago, Amazon released this new feature. It's called east-west routing, which means routing between subnets. I did that in 1999 on Cisco devices. There's these new things called containers. They're almost identical to the private VLANs we were using 20 years ago, which is great. Virtualization of server started with VLANs 30 years ago and switches, and then 20 years ago, Cisco and other people funded VMware, and guess what? Now we've got virtualized servers. It's the same old tech. Route reflectors we use in BGP to deal with non-transitive routing. On the cloud, you've got Transit Gateway Cloud Hub. None of it's new. So XBLMA, why are we going to the cloud? And this is such a good question. It's cheaper not to have to manage all these systems, and it's often cheaper to rent them than it is to buy them because of the simplicity. So what's the point? The fun in this is basically to do this, to take it from one place, move it to someplace else, better, faster, and cheaper. That's the whole reason we're doing this lift and shift. So I hope I answered your question. I don't know if there's lots of noise at Sandeep's house.
Yeah, I think it's gone. Yeah.
Okay.
Thank
We'll
you.
go back
Thank
to
you,
Sandeep, and I'll
Michael.
answer more questions later.
Yeah. Please. Okay, screen is visible. Great. Just. Okay, so here our cluster is ready, and I always suggest store this information somewhere safe, because maybe in a Git ignore, just for your local reference, it's already in the cloud. Because sometimes we need to which is our VPC ID, which is a subnet ID, all that required, right? So have a handy information somewhere. Okay, it will be very useful. So once that's done, I save it in my local file here. Okay, just for the reference for the demo. And if you go to the ECS instances, you can see it's all up and running. So ultimately, what happened that ECS integrated with some EC2 instances, because we selected at the beginning while creating the cluster, we need 2 instances. So they're all auto configured, and that all the resources are now available for our use. But before going any further, what we have to do, we have to create the task definitions. So what are the task definitions? Task definition say how you want to run your container, what is supposed to do, that what and how. That actually explained in the ECS task definitions. So we have to create task definition. You can see their definition task specify the container information for your application, such as how many containers part of your task, what resources they will use, how they are linked together, and all the complicated stuff that we're going to define in this task definition. So let's start that. And again, this will give you selection like how you want to do it: Fargate, EC2, or external. Here, Fargate is a serverless one, and external, if you suppose have your on-premise system, or say your like I have my this small Raspberry Pi devices, if you want to run there, those cases. And EC2, if you have EC2 instances. So we have created EC2 instance cluster, isn't it? So we'll go with the EC2 based cluster. So go with that next step. And there you have to enter the task definition name. So we'll get say sample node app PD. So sample node app task definition, and role, if you like have any like any this container need to access some particular service or tools that you want to give, you can select here. Let's go down. Suppose there's the simple one. Again, you can create going to IAM console and you can create it. Network mode is very important here. You have bridge mode, you have host mode, and you have AWS VPC and none. Suppose you don't want any internet connection, you should select the none. You can see your container will have no internet connection. Suppose you want that that network has to be with the AWS ENI. I think Mike, we can explain the ENI part after this tutorial.
Sure.
There, yeah, and there you can have the common networking and achieve all that. And you can host. Now host networking is like this container will be like run on the same ports as the host, okay, which is like block the ports of the host, not on the ephemeral or virtual ports, okay. And that's bad, because if you want like have like any number of the container open, like dynamic port allocation, you will not able to achieve if it's a host. So you look at the bridge mode, it will virtually create the ports and have create the mapping between the ephemeral ports and the container ports, which we actually want, because you want to have any number of container running on a particular port, like dynamic port to multiple virtual port mapping. That way we can achieve scalability even higher. So that is what you should go for. And task execution role, again, if you don't have any, you can create. I have, so I will just simply select one. Otherwise, you can create new role. It's up to you. Now task memory. So for this task memory part, I want to give say around, I think 600 MB should be enough. Now you know already about your application, how much application memory and how much CPU you need. You should react like you should allocate based on that. Suppose you want 1000 GB. Now again, before allocating that, you have to understand what resource you have. So you have 2048 available CPU. That is a 2 CPU. The 2 into 1024, that is 2048. So one CPU is equal to 1024 unit. Okay, remember that. And you have memory of 1954. Okay, so suppose I want 1 GB for my this container, I can give that. And I suppose I want 1 CP for this container, I can also give that this way. Okay, and now there are all other options which if you need you can enable. For this demo you don't need it. And the main part is adding this container. Okay, this, if you click on add container, this is the most important part, where you want the container name. So say node app container. Okay, and this image, now remember we have stored our image in the ECR. Now we are going to utilize that image for application. Just copy that image. You can see copy URI, copy that, and come to the ECS task definition screen, and there you paste it. We don't need to have any privilege, because while in the task execution itself, I have given the default role. If you don't have, always you can see the create new, it will create for you. The hard limit, we don't want any hard limit. We want to be soft limit. Say suppose you want to run multiple container in the same task definition, you can do that. In that case, you have to equally whatever the application need, you have to assign like that. For our container system, I mean our application, we are giving like we are going to run single. We want to run single container, so we're giving 1000 MB. Okay. So port mapping. Now here's very important. I want to be dynamically port mapping. So I will not give any particular port, but it will automatically map the port, like just like I told you. Since you're using host-based networking, so the port will get mapped automatically. So just you have to give 0 as the host port, which means that we want to go for the dynamic port mapping. And this
okay, let me talk.
Yes,
1 second.
sure.
Let me talk about why you would do port mapping and things. So sometimes when you're dealing with a network environment and you're dealing with a hidden IP address or using something called NAT, meaning network address translation, there's two kinds of NAT. There's the one-to-one NAT, which is basically you translate one address to another address full time. And that's very stable for these kind of things. And sometimes you would do something called one-to-many NAT, where we have multiple devices that are translated into a single IP address. Now, how that works is it's something called port address translation. When we do this and we create the mapping from the inside addresses to the outside addresses, what's going on is there's a mapping of this address to this port number, this address to this port number, this address to this port number. So if you wanted to forward certain ports into a single system, you'd have to tell the firewalls, which are blocking things, allow port 8080 to go in, because that's going to be mapped to port 80 on your container. So it's those kind of things that he's talking about. So I just want to make sure that networking piece we talked about a little bit.
Yes. That's why it's calling port mapping. So you have to map the host port to the container port. If you don't do it, no one will be able to access the application. That's what Mike said, and Mike said excellently. So you need to make sure which host port, like the machine port, you want to have the traffic input, and then forward to which container port. Okay, and we want to just we are saying any port. Okay, for now, but while creating the load balancer, we will say exactly from which port you want, and then all that dynamically will map to the container port. That is what you're doing here. Okay. And again, if you are confused, what is the dynamic port, like what is the container port, go down. See, this is the you exposed, right? This is a port you exposed in the Docker file. That is only the port accessible to the container. So make sure you know that. Okay. And if you want multiple dynamic port mapping, you expose multiple ports. Of course, you can do that also. It's up to you. Now, command, if you want to like have any particular command to check the health checking, you can add it there. For CPU units, we already given 1024. You can give the same here. Now go down. GPU, we don't want any GPU. It's a simple application, and all that is default one. Okay. Now suppose you want to give some add or maybe add environment variables or secrets. You can add via this screen. Okay. And we're not adding any, but if you want, you can either go for the value or value from. Suppose it's something secret, take the value from and then say any value. And value from means the parameter store. Okay, there you can give the value, and it will be either your secret protected or maybe plain text, up to you. For our application, I mean for our demo, we're not giving that. If you want to give any timeout, you can give it. If you want to like disable the complete networking, you can do that, but I will never suggest that. If you want to host the DNS servers, like if you have any custom DNS that should be accessible, you can give, and all the settings are here. Now, these are the
it's
more
very interesting. They use Google's DNS addresses as the primary ones on Amazon. The 8.8.8.8, that's Google.
Yeah, exactly. They given that as an example because many people actually do that. So if you want, you can do it. Okay. Now this needed like these are the all section could like take one session to explain all that. To be honest, it's so much to talk about. But for the sake of the time, so we'll be going like you can do play with all that and find out what all does. Okay, and that's all. Suppose you want to log all the like anything, any traffic coming or some problem happening, you want to log all that. You should enable the auto configure CloudWatch logs, and the log driver should be AWS logs, and you can then track all that. I go down then, and that's it. And simply add it. Once you're done, like this is all we need. And we are using 10 CPU, like one CPU unit, and 1000 GB, like less than 1 GB, because 1024 is equal to 1 GB, right? So less than 1 GB, you can say. Go down and click on create, and that's it. You have your task definition ready. Now we have task ready, we have the cluster ready. What should be the next? Of course, creating a service. You can, and inside service will run tasks. Of course, you can run the task individually, but if it's go out, like somehow, now you cannot take a lot of thing, like something can go down. If you go down and there is no way to provision to make it up again, your application will go down. And if your application go down, your business go down also, because if your users don't see application working, they will just use someone other application, right? And you don't want that. So definitely copy the task definition because we'll need it. And this is our cluster. You can see in the cluster you have services, you have tasks, you have instances, metrics to understand what happening with the load and all. We have scheduled tasks. Suppose you want to run on particular task, maybe having some cache creation or maybe some schedule batch file generation, everything you can do that here. And if you want to have any tags, you can add it here. Capacity provider is a very excellent thing. Suppose you want to have multiple variety of instances you want to run, want the load distribution, have advanced scalability, you can do that. I'll be not showing in this session, but maybe in future session I'll be definitely hand that. In my channel, there is a separate video just on the capacity providers. You can watch that. So we will go with the services. So simply click on create service, and here now very follow this is very important, because in production systems or high performance system you always use the service, not the individual task. And here you get the option Fargate EC2 or external. We have created the EC2 configuration. And the task definition, this is a sample node app TD. In the cluster, of course, sample cluster. Service name, we'll call it node app service. Okay. You need a unique service name, which will be required to identify the application. Replica, we want to run symbol one replica. Now you can also run multiple as you want. But I personally suggest that running the auto scaling, because if you have the requirement of more applications, simply yes, based on the load you can define that. If you don't have any, there is no point running more services, which will cost you more, right? Now number of tasks, maximum healthy person 100, maximum healthy person. And now this is why needed, because suppose there is some scaling requirement, how many you want all that happen at once, that is the level. So since you are mentioning the healthy persons 200, that means two instances can be like one running in the background and one can be newly one launch and processed, that kind of deployment circuit breaker. If you want, you can have it. Okay, that is like if something bad happens, what you want, that kind of case. Deployment type, rolling update, it will happen one by one. If you want like one like happen like very separate network level, separate network, all the resources created and it all works well, then automatically change the application traffic to the new one, which is called blue-green deployment. You can do that. Now I'm not explaining in details, but if someone want me to explain blue-green deployment in more greater depth, I will definitely do it.
Why don't you do that, Sandeep? Because
Okay.
I've got some architects that may not be as familiar as I'd like them to be with DevOps things. Obviously, architects don't do DevOps, but I want them to be more familiar with the process. So if you could describe blue-green deployment, I think that'd be
Definitely.
great.
Okay, so rolling update is something. I will start with the rolling one. Okay.
Okay.
So rolling update. Suppose you have 10 tasks running. Okay, task mean the 10 container running in more simple language. So and you have some code changes, and that change going to deploy to all 10 containers, whatever running container are. You can do all at once, but the problem is that if you try to do update all at once, there will be service downtime, which will problem because you don't want your customer to get offended if they can't access service. Even in the night, there are some night owls like me who want to access some server. If they don't get it, I simply straight send the mail to the admins, right? Which you don't want. Okay, you don't want your customer to get offended. So what you do it, you can do it slowly, one by one. Suppose you want to be one by one, and in that case, the one server get updated, and after that is done, the next server will get updated. After that, the next one, and there will be a backup also. You're not maybe it could be that way also. You create one new instance which have all the latest change, okay, and that will replace the older one. You can go that way, and this is what here actually happens. You can see 200. That is, you can have double of that. So you have one instance, then one task running, new very separate task with the latest version we created, and after that is stable, it will replace the existing one. Okay, so that is the example of rolling update, where you update one by one your all the running containers. Now blue-green is deployment is very different, where you say of course you can do all at once, you can do 10% at a time, what your deployment configuration are. But the main part is here that say what is blue. So in blue you have your all old container or old running task, okay, and in the green have the container with latest all latest changes, and exact it match exactly the current running number of tasks, okay. And if all the running tasks are perfectly working fine, all are okay to accept traffic, simply in the DNS level it add the change. So old like any old resources traffic they're receiving, there will be either like whatever configuration you choose. Based on that, the traffic will be switching either 10% at once or maybe 10% in a minute, whatever the configuration that you chose. Based on that, the traffic will slowly go increased and finally move to the new, that is the green environment, or you can say who have the latest code changes. Okay, that is the green deployment, where you have everything latest, all working fine and good to go there. And if something bad happens, you can easily roll back to the blue one, which is the existing running one. So you don't immediately destroy it based on the configuration you do. After that only, this gets the blue get destroyed to save the cost. Otherwise, if anything bad happens, you can always move to the blue, which actually is a great system. Something bad happens, there is a very very less time in the system, because you have everything in backup. If something bad happens, you go to blue. If all good, you can simply move to the completely to the green one. So that is the reason why blue green deployment is very popular, because it's guarantee you the zero downtime. Okay, but again, sometimes it's great to go with the rolling update. I will give you example, like you're running a socket or IoT application. Suppose you suddenly make all the changes and all the traffic to the main one, that will be problem. But again, if you do percentage while, Brooklyn also fine, but that's costly, because you are creating a lot of other resources standby mode, right? But if you don't have that budget, you can simply go with the rolling update. So based on the budget and the complexity you want, you can go for that. I hope you guys understand this. So Mike, any one question you can definitely ask here.
No, I think you really did a great example of describing it. I just wanted people to understand how it's migrating part, test, and then go
Yeah.
full blur for the non-DevOps. I think this is really great. And then we'll talk about, some people asked some other questions about the VMs, and I didn't drink enough coffee this morning to truly answer the question, so I'll do that a little bit more later. I'm trying to get off the
Sure.
caffeine, but keep doing what you're doing, Sandeep. It's really great.
Sure, sure. So that is we're going with the rolling update. That is a placement template. So where you want your task to be placed, okay? And you have a lot of options. So balance spread. So as I mean ability zone. Suppose you have three ability zone and you want to run three tasks. So each ability zone will have one task. Suppose you go with the balance pinback. So you have three application. It will go to the three ability zone where they have the least number of the memory available. So they can just fill that right up. Not actually least, it should be wherever you have the most available, there will fill it up. Okay, bean pack. So this template, actually you can see the definition. This template will pack tasks by the least number of instances by memory. So where you have the task memory available, fill that up first. So first one, whichever you have the available, go there, and that will, then after that any new task will move to the next one that way. And if you have one task per host, it will make sure, suppose you have 10 instances, okay, 10 EC2 instances, you want to have one task per instance. That cases, this is the one task per. For our use case, we'll go with the bean pack. It will make sure you use the like resources to the fullest. Okay, and of course you can enable the tags if you want and all. Go to the next step. This is one of the very important part, where you say we have application and it's supposed to accept traffic from the outer world, right? Now how can you accept traffic? Of course from the load balancer. And you can have, like, of course, you, if you run your task even independently in any EC2 instance, and bind that using either bridge or host based networking, that also can access the internet, but that's not the right way. If the task goes down, your application goes down. So best way is to use the service and with the load balancer. And most cases is the application load balancer, when you have the HTTP or say socket application. Okay, and if you want to have network level, like network level TCP application, for that you go with the network load balancer. Classic one is no more actually utilizing, is depreciated. I never suggest that one. So we'll go with the application load balancer.
Sounds great. Why don't we
Uh,
pause there for just 1 second, and I'll talk
Sure.
about the reasons why people would use certain types
Sure.
of load balancers.
Sure.
So we have the architecture piece. So as Sanjeev mentioned, in many cases, you're going to use an application load balancer. Routing between microservices, routing between containers, this is perfect. They're the least expensive, and they're the most intelligent. Now, in the world where I work, where I'm dealing with these big 128 core servers with 4 terabytes of RAM and a whole bunch of them, the application load balancers are not going to have that horsepower. So what happens is these application load balancers are smart, and they're looking into so much detail into a header that they can't do anything fast because they're smart. So in my world, where I'm dealing with big monster computers, I'm using network load balancers because the network load balancers are fast because they don't do so much. So application load balancers, routing between microservices, lots of intelligence in what you're doing. Network load balancers, and you need speed and performance. Classic load balancers, guess what? It's just an application or a network load balancer with a new name that's a little older. So really your only two options, architecturally speaking, are always going to be application load balancers and network load balancers. So
Exactly. And see, if you want this function like dynamic host load mapping and all, or maybe you want to use the socket applications, it's easy. Like if you want everything to build in kind of way, you can go with the load balance application load balancer. But if you want very like excellent performance, faster traffic handling and all, that you should go with the network load balancer, as Mike said. Okay. So for our application need, we are definitely going with the dynamic load balancer. Sorry, the application load balancer with the dynamic host port mapping feature. Okay. And see, right now I don't have any load balancer, so I'll definitely go to EC2 and create one for our need. So simply go to EC2, and then see you have the options. So network application load balancer, you can see, and they're saying the reason also why you should going to use the application load balancer, why should you use the TCP network load balancer, and why you should use the gateway load. So, and this is the new one. Am I going to explain about the gateway load
Yeah,
balancer?
sure. So in a normal environment, we're using these physical load balancers and these physical firewalls, and these things scale. They've got ASICs, they've got FPGAs. They are massive and they are powerful. When we start going to the cloud, we've got a couple options. We can use these lightweight security services such as WAF and Shield, and they're very good. But if you're an enterprise and you're dealing with a need for extreme security, you're going to need something more. So this is where traditionally an organization would use a Cisco firewall, a Palo Alto firewall, things like that. So the gateway load balancers basically means that you can set up multiple EC2 instances for which you're running your enterprise security, things like a Palo Alto firewall, and this will load balance it for you. So the gateway load balancer is a way to work around some of the limitations in the cloud with regards to not having your physical devices. So load balance between any kind of appliance you would need. That's what the gateway load balancer is for.
Right. Excellently explained, Mike. Thank you.
Thank you.
So, of our use case, we're going with the application load balancer. And let's give it a name. And I think the UI changed. Okay.
They always do.
It started. So it's okay. I think it's good. I mean, you have serving the latest content. Great. So let's call it Node App LB, load balancer short form. We want it to be internet facing. Want it to be IPv4 because in the VPC we didn't create it for the VPC. Sorry, IPv6. So we go with the IPv4, and then so this is very important. Now, why I told you to have a reference of the instance that you created. See, the VPC ID is at the end. Just remember the last four: 3D33, and make sure that is the one you should select. Otherwise, your application load balancer not going to connect with your instances, of course, because it's not in the same network. So make sure you understand that. So let's find out the name that is 3D33. Again, just make sure you know 3D33. Yeah, this is the one. And we had I think while creation we had these two default subnets. So we'll go with that. Then security group also we will go with the default one. Listener is very important. We want to accept all the traffic from port 80. We are not going to utilize the 443 because we are not going setting any HTTPS for application. And let's say now that is fine. Default action thing. Now this target group, let's create a default target group because I think default one is needed. Right now it's not showing here, but it's very needed one. And this is okay. Okay, let's try to like without load balancer, without listener, and see if that doesn't work. We'll do it because it's a new UI. So let's try to understand that. Get a load balancer. Oh, that's needed. Okay. And target group place default. Actually, we'll be not utilizing this default one, but still, it's a very you have to use it anyway. So default node LP teaching target group 480. Or you can see 3D33.
Is that how you spelled it on the other side?
Which one?
Is that how you spelled default on the other side?
Yeah, default.
Okay, perfect.
Oh, the misspelling?
Yeah, it looked like it was misspelled, which would be fine if you misspelled it on both sides.
It is
That's why I
fine.
was
It's fine.
checking.
It's misspelled. So it's typo error. It's okay.
I make
So
them all
default.
the time.
Good. And you can see the health check, which is okay. Just go with the default one for now. And tag next. That's it. We have now created a target group. We will not select anything. Make sure to remember that. We just want the name. That's it. Okay. Let's click on that, and I think it will be available. Yes. It's available, and we will be not utilizing that, to be honest. If you want, we can, but it's up to you guys. You want or not. So let's create the load balancer, and that's it. So next, successfully create the load balancer. This is the one. Now we have very important task to do first. That is find out the security group of this load balancer. This is the one, and make sure it's allowing port 80 to access the traffic. And I think it's doing it. Let's see, it's allowing port 80. Yes, it's allowing port 80. All traffic. Make sure to edit and check. For now, let's make it like anywhere. IPv4. Okay, we cannot do it because anywhere is, what is that problem? It's okay. We can add another rule and say we can just, oh, that is all traffic. My bad. So we want a port 80 to be like HTTP port traffic to be open, and it to be anywhere IPv4, and that's it. And this is allowing same group. You can see just to make sure all resources go same pathway. So we're saving that, and we are making sure port 80 is allowed. Like we want anyone in the internet to access this application. So we have the port 80. And the next thing should be, let's go to the here and then go to the ECS cluster. We have to make sure any traffic that comes from the load balances should be allowed. To do that, we have to go to the security group of the running instances. And you can go to the running instances here and then click on any EC2 instance. Let's wait for the load. Say this one. And click on the security tab, and it will load the security group. So click on that. Now you have to, that's why it's very important, because we added the load balance in the same VPC. That is the reason we will be able to like add that security group as the valid source. So add the rule, and we want all TCP traffic from the load balancer, like custom, and is the load balancer, and this is working. So now it's easily can get the traffic from the load balancer allowed on all port, because we want the dynamic traffic mapping or dynamic port mapping here. So save the rules, and we should be good. Now we have everything in place. Simply come to the, let's see where it is. Yeah, load balancer here. Refresh it, and you can see our load balancer is now available. We have this here. We can see this is the option. We can create a new one, and or we can like select the existing one. It's up to you. You can see port 80, the production listener port. You can create one, but since we already had one 80 listener port that we have created, and you can actually utilize the existing default TV, that default load balancer. The problem is that you cannot change the traffic pattern. Okay, that's a path pattern, but we have a microservices approach in an index. As you can see, you want this to be global path, and this to be the application accessibility or the application name. Based now we can have any number of application route based on this to be the base path, just like this status. Okay, for that reason we cannot use the default one. That's what we'll be not utilizing that. We'll be utilizing this. So again, this one, and we can call it ECS node. Let's keep it short, because otherwise we'll get error. Okay, and this is the one that we want. The default path should be this. Okay, copy. Make sure you don't do mistake in the path mapping, and evolution order should be 1. Now here health check path. So health check path is this. Done, and we are good. So we have created the application. If you have any doubt, you can do like this is fine. This is the where people make mistakes. Make sure it's only single star. Okay, so all good. And services, node app service. services, node app service. If the path doesn't match, it will fail. So make sure you have that and have this there. That's it. I'll check paths. And this is the where that it's make sure that it receive a 2000 status code. Otherwise, it will acknowledge that service as a failed service and will keep trying and trying. We don't want that. We want to be running, right? Next step. Now this is the part where coming to the auto scaling. Suppose a single task is not enough to handle a load. That's why you need the auto scaling to be. Let's say there's too much load. So based on the custom metrics or based on the CPU load, whatever your target metrics are, based on that you can add new number of the tasks to support the service, okay, so that it can handle the workload. So let's say for our example, we'll go with the minimum number of tasks should be one, this should be one, and the maximum should be one. But if your application actually need kind of more number of tasks, you can have it like say 10 or 100 based on your use case, okay. And you need a role. If you don't have any, you can create one for you. And there you can see target tracking. Now easiest one is the like target tracking, but if you in production application, the easy target scaling is not enough. You need a bit complicated step scaling based on different policies. You can add it, but just for the sake of simplicity, we'll go with the simple tracking or target scaling policy. So and we'll call the policy as high CPU. And service metric is, you can see CPU utilization, you can have the average memory utilization or the ALB request count. So number of the request per task, you can define that way. For our use case, we'll go with the high CPU. So it's high CPU and target value. If it's more than the 70%, it will create a new task. That kind of rule I've set here. So and if you can see default scale out cooldown. So after this second only the scale out will happen. And if suppose any like one, suppose you created one task, after 300 seconds only there will be new task. That kind of rule, and you can should be configuring that based on your need. Your application have too much traffic, this should be less time, okay. And suppose the scale in, there is not much load, an application need to be scaled in to save the cost. You can mention what the time should be minimum the application should be up, okay. Or minimum should be the newly created task should be up, not go down. That is a rule you can set here, like how much how much seconds you can sit here. And scaling, like if you don't want to enable the scaling, you can like disable the scaling. So if you created new task, it will not get removed. Now it's again based on your application type, you should be defining all that. Next is okay. So you have all that. Here you actually come and make sure you review that all the configs are fine. Make sure this health check path or the path pattern actually map with your application architecture. So it matching, okay, all good. Then create the service, and it'll take few seconds, and then will be all created. I think while this create, you can take new question. I mean, take the question from the people.
Sounds good. So I want to do one thing. So some Naga says it looks like you're having fun. Now here's the thing. You and I love to teach, and we love the tech. The reason I love working with you is you love it so much that you work hard at it and you became great at it. Same thing I did with networking. I locked myself in a room and became a CCIE within 6 months of leaving medicine. I mean, one day I'm practicing medicine, 6 months later I'm a CCIE, back when it was a two-day test, reading 75,000 pages of materials and not having a day off in 6 months. So when you really, really love someone. Now I want to go back to that question was, what's the fun in the lift and shift? If all you're doing is taking something from the data center to the cloud. So I want people to think about the agility of the cloud from the architecture perspective. Here's the way we normally build our systems. Let's say we've got a retail store. We buy these servers that are big. And the reason we do it is there's like 2 or 3 days during the year or 10 days where we've got all this demand, and the rest of the time our demand is like this. So when we're dealing with retail stores, let's say we've got an environment, a big retailer, we might have 100 web servers that all have 120 cores and 4 terabytes of RAM, or even 1,000 of them, to be able to scale to Christmas, which is the biggest time in the US. Where with the cloud, we might only need 10 of those servers running all year long, and then when times come up, we can just scale up. So the auto scaling, that kind of agility is what makes the cloud cheaper. So it's the simplified networking, meaning you don't have to build a network. You don't have to buy the 40,000 routers. You don't have to buy all the WAG connections, but the agility, the ability to create an instance in a second, The ability to auto scale enables us on the cloud to purchase what we need normally and then add capacity as needed. So that's why organizations like these lift and shift. There's nothing special about the cloud other than the agility. It's a data center. Guess what? When you add hypervisors, you reduce the performance of the data center. You can't get the IOPS in the cloud that you can in the data center. 64,000 IOPS is the max that you're getting with an EBS volume, except for the new ones, which are 250,000. That doesn't mean the cloud's not great. I can go to the retail store and buy an NVMe drive for $200 that gives me 500,000 IOPS. And so, I mean, we can do better performance in the data center, but we can't scale like this. We have to overbuild. We have to maximize build. On the cloud, it's like ding, ding, ding. But okay, more capacity. Don't need the capacity, shut it off. So that's where the financial performance is done. So while we're waiting, if we have another question, I'm always thrilled to take questions. Chris, do we have another question that's here?
I think we are just done with the services ready. Let's show that and you can start asking more questions.
Perfect.
Okay.
Great. I didn't know how long it was going to take to get ready.
So it's done. It's done. So you can see the task is running. Did you start sharing? Okay. You can see the task is running now. Sample app node TD and running. And just from the EC2, we can get the load balancer URL that is here. Let's copy it here. And then we have this application path. So let's copy that and paste it here. You can see yes, it's running this sample app response from service 1, Node.js service, which is what you're expecting here. It's a response. And it works. Ta-da!
Excellent.
So we have from local to cloud, just like that. That's it. We have the migration.
So you tied your container, you packaged up your container, you transported your container, you built the container orchestration with ECS, and then you just deployed your container, and then you fronted it by a load balancer.
Exactly.
Excellent. Now, in the data center, you know how long this would have taken? First, we'd have to buy the server, okay? And then, we'd create our containers on multiple servers, and then we'd have this, F5 load balancer. So we'd have to wait the 6 weeks to get the servers. Then we'd have to install the control plane on it, and then we'd do these things. So now you can see how much faster this is. That's the agility of the cloud. That's what organizations love this cloud. There's no calling Lenovo. There's no calling Dell. There's no calling HP. There's no calling Cisco. There's no waiting for it to get there. Waiting to and making you have to hire a person to basically rack the server, unbox it, rack it, screw it in, cable it, install it. So that's why people like the cloud. That's why these lift and shift. Sandeep, great job migrating that.
Thank you. Thank you, Mike.
Great job. So at this point, questions from the engineering side for Sandeep, questions from me. I know Chris from my team has been aggregating questions from Facebook and LinkedIn and YouTube. So, okay. So I have 6 years experience in your certified solution architect associate, not having experience in AWS. How do you prepare your resume and for the interviews? So that is a really great question, Mr. Shah, that I don't know which kind of job you want to interview for. So if you're interviewing for an architect job, it's going to be one thing, and it's going to be a very different path to interview for an engineering job. It would be very different to interview for a SysOps job. It would be very different to interview for a DevOps job. So I don't exactly know what kind of job you want to interview for. If you tell me, I would love to answer it. Every one of these jobs requires a substantially different resume, and every one of them requires a very different interview process. If you let me know, I can help you out with that. Love to give you more. They're so different. I have to be careful that we give you the right interview. Just procure VMs, network, and storage is enough for cloud migration and middleware migration to decide? Well, yes, but here's the thing. It's that simple to do it, but you have to know what you're moving. Now, that investigation process of knowing what you're moving is extensive. I worked with a global bank one time when we were designing their voice system. I had 16 engineers that were there for a year evaluating all the current system to give me enough information that I could actually design it. Then I did the design, and then the engineers built the proof of concept. So realistically speaking, the whole cloud is nothing more than a network and a data. So that's it. It's the same 30-year-old tech that we've been using forever. Nothing's new. Every new feature, I could show you a 30-year-old example, which is great, which means if you learn the network and the data center, you know how to architect things on the cloud. If you ask how good legacy web privilege to move on the cloud, the only great question. So the only reason Naga, the cloud, is so good for these applications is it eliminates the need for the complex networking, And in the data center, we've got to build for max performance. So we've got to oversize it for our busiest days. On the cloud, we purchase reserved instances for the cheapest price, meaning we're going to buy a long-term commitment for the cheapest price, and then we're going to use auto scaling to add on demand. That's the massive benefit of the cloud. That benefit itself is major. Organizations may have servers that literally run at 10% of the year. They build a network that's at 10%, 90% of the time, just for that one time where they have the big orders. So with the cloud, you don't have to do any of it. That's Naga, how it makes such a big difference. Next question. Some will be for me, some will be for Sandeep. Shang, always so good to see you. Thank you so much for this presentation. My challenge now is to determine which route to take, SA or DevOps. You have great interpersonal and customer-facing skills. So Shang, there's two options. If you're like me, and you like meeting with clients, and you like delivering presentations and calculating business requirements and designing the system, architecture is the right thing for you. If you don't like being in front of the customer and you really like to get your hands dirty and you want to know the intricate depth of all these things work and how they work, and you love that, like Sandeep, he loves the tech. I love talking about the tech. I love convincing customers how to change their business because I love business. If you love that tech in the weeds and you like to configure things, and you're one of those people that in your house, if you have the ability to use your phone to turn on and off your lights and open and close your doors, if you're that kind of techie, you want to be an engineer. So the key with DevOps, I'm going to make this really clear, saying, is a lot of people have it in their mind that all they have to do is pass an AWS DevOps professional exam and they have the DevOps job.
No, here actually want to add something. So because people think having certification is enough and all that, but see the real life skills. If you suppose even someone not use the container explicitly or not actively, but having the knowledge that there is some containerization technology, and if any application have the requirement meeting the requirement with containerization, you should suggest that. So that knowledge is also required, which this kind of certification doesn't cover. You need some real life skills, real life experimentation to find all that. So that is also important. That's I would add it here.
So important. And so you got to understand that. So Shang, it's just, to me, when I see people being pointed to the certification and think they're getting hired, it really scares me. So Shang, if you want to take my call at 12, we will tell you everything necessary to how to become a cloud architect. I'd love you to join us. Now, Sandeep, what are the traits of the perfect DevOps engineer? How do you become a great one? What do you need to learn first, second, and third?
So first is like to become DevOps engineer, having a knowledge of how the development works or how the development lifecycle works is too important, because you're supposed to work on that. If you don't know how the development works, that's bad. You need to have the knowledge. You need to know where the code gets stored, how the code gets built, like using the system like Docker or similar kind of system, how that container image, all the final output, we call it artifact, the final output, you want to move to a cluster of system, and you have to run that binary on the servers. Could be Node.js application, could be Go, could be Python, could be anything. You have to run that in a production systems. That knowledge, how to do that is crucial one. Then to do that, to run from one to having generating the builds, saving running the build in those kind of cloud systems or cloud instances, you need to have knowledge of what are the Linux are, because everyone know 90% of the servers are on Linux. So if you don't know Linux, you cannot do that. So you need to know Linux. Now, to run this application, to generate the builds, to have this automated flow, you need some scripting, because to generate all that, running one by command is not enough. You need some dynamicity. You need to have some having output from one command. You have to utilize that command to get the next step, or the could be anything. Could be dynamic file path generation. Could be minimizing the file. Could be anything. For that, you need the shell scripting. Now that is there. Now, if something get complex, because shell scripting is complex, everyone know that. You cannot have everything using the shell scripting. Sometimes we need one programming language. Could be Java, could be Python, could be Go, could be Node.js, anything. You need to have some kind of backend knowledge which interacts with the system, or you can say the kernel. That kind of knowledge you need. So any one programming language, if you have all the knowledge, you are good to go with the DevOps part. That is all it takes. Okay. That's a basic.
Thank you, Sandeep. That was so critical that you mentioned that, because every day somebody says, I want to be a DevOps engineer. And I say, Or an architect, I'm not sure. And I say, do you know how to code? And they say, no. I said, do you want to learn to code? And they say, no. I said, then we can move you into architecture roles by teaching you how the systems work together. Because we architects, it's this piece fits with this piece, which fits with this piece, which fits with this piece. We're not going to code. Now, if you want to be a DevOps engineer, you got to code and you got to understand all this stuff long before you can learn DevOps tools. So thank you for that, Sandeep. It's really important we give people the tools to how to build a career. I'm really excited to our first How to Get Your First DevOps Job program that we're going to build using all of our experience getting first jobs and really capitalizing on that super incredible knowledge in your head on how to be a great DevOps engineer. So who has the next question? Chris, who has the next question? Nacho Max. Yes, of course you can have a PCI or HIPAA certified infrastructure in the cloud. They're very compliant. Now, the cloud really isn't the determination of whether it's HIPAA compliant or PCI compliant. It's how you actually architect the solution. So for example, in HIPAA, there's a bunch of rules, like millions and millions of rules. One of the rules, so for those that don't know, HIPAA is the Healthcare Information Portability and Accountability Act. It governs healthcare privacy in the United States. So for example, it's got rules of who you can exchange information with. So if I'm practicing medicine, something I've got lots of experience doing, and let's say Sandeep is a physical therapist, and I were to send my patient to Sandeep, the physical therapist, I can say, Sandeep, please evaluate and treat my patient their post-hip replacement. And he would know what to do as a physical therapist. That's the way that's there. But by comparison, if my wife wants to know about the patient's broken hip, I can't tell her because she's not involved in the patient's care. Now, my wife also practices medicine, so if I ask my wife to get involved in the patient's care, I can do it. So that kind of workflow, that kind of compliance, Nacho Max, is really what's going to set up the stage. But you have the capability in any of these clouds to make a HIPAA-compliant infrastructure. Hope I answered your question there, Nacho Max. Okay, XBLMA. Well, I'm going to give you the real honesty here. These are opposite careers. So I love DevOps. I think it's one of the ways to innovative changes for the future. I think it is one of the top 5 careers moving forward to have the best careers. I love cloud architectures because I also think it's one of the top 5 careers moving forward. In fact, I'm releasing a video series of the best cloud jobs for people to do that are new to tech, for freshers, but also people in general. So I feel so strongly about this. Here's the thing as an architect. Here's the architect skill. Design. So the architect needs to know the stuff they're moving, which is basically the network in the data center. So that means the routers, switches, firewalls, IDS, IPS systems, load balancers and how they work in depth, storage, servers, for server virtualization, containers. That's architect skill. How do the pieces and parts work together? Then it's how do you design the pieces and parts, how they work together? And then it's about presenting and documenting and selling. So it's an emotional intelligence, executive presence, communication, customer-facing role. DevOps is something different. It's building and automating software release cycles. It's building and automating releases in the cloud. Here's the biggest problem. When you're a really great engineer, nobody wants to let you become an architect. Because when you're an engineer and you're really, really smart, people view you as an engineer. And then when you want to go be an architect, they're like, no, we need a business person for that. And I'll tell you, when I wanted to go from engineering to architecture, here's what I had to do. I changed the way I dressed. I started wearing a suit to work every day. That was the first step that I did. I changed the way I spoke. I took about $250,000 of leadership training and soft skills training. I pretended not to be technically competent. I literally went there and I pretended I didn't know half of the things that I knew. And I'd go up there. I was wearing a handmade suit because it was necessary for the job. I'd go talk to the clients. I'd ask about their business problems. 6 months later, nobody knew that I was still a tech professional. They thought I was a business leader that knew high level how the pieces and parts work. Boom, I was an architect. So the deeper you go into engineering, the harder it's going to be to become an architect. So I definitely don't recommend that. I recommend if you want to be an architect, be an architect. If you want to be a DevOps professional, be a DevOps professional. If you want a doctor, be a doctor, go to medical school. Don't go to veterinary school and take care of cats and dogs. I love cats and dogs, but train for the career you want. That's your best way to get there, XBLMLA. And we'll answer that very clearly and give you all the steps if you desire the cloud architect thing. In a webinar, we're going to do it in the DevOps thing. Well, expect it soon on how to get your first DevOps job. Women are coming from Sandeep and I, but for right now, that's a future one. Oh, and regarding these job posts, when they just post anything, these job posts are basically crazy. Here's what goes on. In an average company, it takes 3,000 people for a single hire. In a high performance company, it takes 5,000 people. So what HR does is they don't want you to apply unless they think you've got a million years of experience. So HR puts up silly things for this. And then they're trying to get you not to apply. And here's what happens. They get all these people to apply with all these skills. They go to the hiring manager. We hiring managers interview them. Like, I'm sorry, you're not an architect. So then what we do is we say, the heck with this. I'm going to call my favorite tech recruiter. And when I call my favorite tech recruiter, here's what's going to happen. The tech recruiter is going to send me someone that I know that can do the job. And I'm going to call them and say, here's what I want. So that's realistically going on. So here's what I want you to actually understand. The people that make the hiring decisions are the people that have the money, meaning the executive team. The executive team does the hiring decisions, not the regular people. So the executive team determines, and there's a reason I'm telling you this, where the money goes. So if you're the chief information officer, you tell your VP of IT, I need a cloud architect. Who tells your director of IT, I need a cloud architect? Who tells the hiring manager? These job descriptions have gotten so crazy. I mean, they're so far from what we actually do that Gartner, an organization that evaluates technology, basically said this. We're going to go ask chief information officers, what do you want in your cloud architects? Because these job descriptions look like they're coming from planet Mars. They've got equal parts software developer, equal parts Olympic sprinter, equal parts DevOps, equal parts maintenance person. It's crazy. So what happened is as follows. Gartner interviewed CIOs from all over and they said, what do you want? They said, we don't understand these job descriptions. They're absolutely insane. What do you actually want in a cloud architect? Because architects don't do these things. And here's what came out. According to Gartner, and this is published in CIO Magazine, I'm going to drop the link for it in YouTube. And here's what, just so you can see that it's not just me. This is what the people with the money, the people that are really responsible for the hiring decisions say. They want a cloud architect to lead the cultural change for cloud adoption, leadership. That's what I've done for 25 plus years as an architect. Then they say develop and coordinate a cloud architecture. Again, that means design. That's exactly what I've done for 25 years. By the way, that's all the architects that I know working at AWS, GCP, Oracle, Azure are all doing the same thing. Then it says develop and coordinate a cloud strategy. Again, this is design and leadership. Then they say helping to find talent with the necessary skills. That's leadership. That means hiring. Then they say assessing application software and hardware, just like I was talking with Sanjeep. What do you have? What are your systems? How does it affect things? Then they say establish best practices for the cloud. That's a leadership thing. How should people use it best? Then it says selecting cloud providers. Again, architect, now I go with AWS, GCP, Azure, or all three combined. Then it says working with the IT security people to make sure that the security systems are to monitor privacy and develop incident response procedures. Then it says manage budgets and operating costs. And then it says upright at scale. Note, you heard nothing of scripting, nor will you ever. You heard nothing of configuring, nor will you ever, because we architects just don't do that. We design. So I don't even have my students apply for jobs. I send them right to one of our recruiters to have them find our recruiters, stick them right in front of the hiring manager that knows what they want, and that way they hire people. And the problem is so bad with the wrong people coming up from HR. Employers will pay $20,000 to $50,000 just to find a good employee, just to bypass HR, because they can't interview a jack of all trades and a master of none. So if you want to be an architect, train to be an architect. You want to be a DevOps engineer, train to be a DevOps engineer. You want to be a podiatrist, train to be a podiatrist. You want to be a football player, train to be a football player. You don't train to play football by swimming. You don't train to be an architect by doing engineering. And you don't study to be a podiatrist or a doctor of the foot by learning about the hand. Learn the skill for your job and you'll be in great shape. So that's the best advice I can give you. Focus. That's what I've done. That's what my students have done for decades. And they've been wildly successful because of it. Well, here's what I will say on this one, Sujit. The more you're closer to the customer, the higher your salary will be. So the saddest reality is your engineers are probably the smartest people in the bunch when it comes to technology. An architect job can be 2 or 3 times higher pay because the architects are building and designing the solution and selling it to the customer. So as an architect, the reason our pay is so high is we're speaking to that CEO and we know how. We're selling a $100 million design, so we're bringing in the money to the company. That's why architects are paid so well. We bring in the money.
But here also difference, like there are engineers who get a lot like more paid than the architects.
Yeah.
There are architects who could pay more than the CEOs. So you have to understand that
Yeah.
positions and all that matters based on the experience, based on the like talent or skills you have. A lot of factor that you cannot imagine, to be honest. So I mean, in the just of luck, you can more than so all that matters. So I think most important reason will be your what you're talented on and what kind of experience you have. The more bigger, the better, and the most unique skills you have, the more get you like the more you get paid. So that's what important. Not the position,
That's
but
half
the
of it.
skills important.
So it's
Right.
50% technical skill
Yeah.
and it's 50% communications.
Exactly.
I had a
Communication skill.
manager who was about 20 years ago, and he said, "Mike, do you know how you go from a $100,000 a year engineer to a $300,000 engineer?" I was like, "Tell me." And he said, "Soft skills, emotional intelligence, executive presence." And you know what? I spent $250,000 on soft skill training and emotional intelligence training, leadership training. And all I'll say is it paid for itself very, very quickly. So your salary is determined by your skill as well as your
It's
communication
communications.
ability.
Right.
Those two factors. So if you want to get paid more, you'll get paid more in any role when you communicate. In fact, lots of organizations invite me to pay and train me to teach their engineers to make sure they can communicate better, because it doesn't matter how good it's in your head when you have to communicate it to the customer. So yes, I've seen lots of architects that earn a lot more than a lot of CEOs. I've seen some engineers that have gone to some specialty things, like they've got a special unique skill that no one else in the world can do. I've seen them get paid 7 figures if they're that good. But as a rule, in most cases, the time you're closer to the money, the more you tend to get paid, especially in the US and the UK. And to that point, yesterday we had a video on, things to do for freshers, how do you get your first tech job? And we've got this series. First we explained the problem. And now we're going to give you recommended careers. And we're going to talk about recommended skill sets. Then we'll talk about recommended certifications. That's the key. And one more important thing is that what determines your salary is as follows: how much knowledge you know about one thing. So the jack of all trades that knows a little about a lot of things is going to be the lowest paid person. The person that's really an expert on one thing. Like for me, it was BGP for 5 years. And then it was IP multicast video for the next 5 years. And then the next decade, I worked on healthcare architectures. Why was healthcare architecture so good for me? Because I can practice medicine. So I was instantly relevant in terms of my clients. So I had a specialty: architecture plus medicine. So I was the healthcare architect guy. So your pay is going to be determined by those kind of factors. The more you know, the better, more capable you are in one thing, the more your specialty, the more you're paid. So be an expert on something. Oh, interesting, Sujit Kumar. Yeah, you can't expect a person to know anything. A doctor goes to schools for 17 years for entry-level practice after a fellowship to do one thing. And they do it for the next 50 years. The 12x AWS certified, the 10x AWS certified person to me is a joke, because basically that means they know so little about a lot of things. I need somebody that knows a lot about one thing and be really good at it. How and when does the cloud architect get success in migration project? Does he need other stakeholder support? Wow, Naga. The cloud architect needs 1,000,001 stakeholders for support. So this is the reason the architecture skills are so communication oriented. First, you're going to need the CEO support to buy it, the CFO support to buy it, and the CIO support to say this is the right thing. Then when you go to the cloud, realize you're most likely taking a lot of people's jobs away, because someone like Sandeep in the DevOps environment can do what 10 or 15 regular people could do in the traditional data center. So they're not going to want to talk to you as an architect. So you're going to need the executives to basically convince the employees that they need to talk to you. So you're going to need their support. Then you're going to need the support of the hiring managers. Then you're going to have to convince these employees that know that you're maybe taking their jobs away to talk to you. So that requires tremendous emotional intelligence, soft skills, communication skills. Then it takes the leadership to try and work with those people that you're getting the information from and trying to make them allies and trying to find better jobs for them when you're done. because the job that they're currently doing probably won't be there anymore. So if you can train them in the process or point them in the right direction so their skill set is usable, they can save their job. So that's part of it. Then you need to make changes. So that requires change management. So that requires every stakeholder and every organization to get involved. So that's why these architect jobs are so basically high paid, but also so customer facing. You can't do it without getting the support of an incredible number of stakeholders. So that's why, the training of here's the name of the service and how to configure it, not only did it not give you the technical skills, it doesn't address the main part of the architect work, which is the human side. You have any thoughts there, Sandeep?
I think here, one part I will say that just in the question you can say that people want to actually do the migration and all, and they actually look for some support, some documentation, and actually there is document of course everywhere, but there's very less documentation to be honest. And I think that is one of the reason why I make a post on this complete migration step. I think can I share the link? I don't think it's an option, but there's a complete flow, like how the like from very basic the code to entire migration works, what are the person need to be involved, and because it's not a single corporate person can do all that, because the data team working on the data parts, the development team working on the data like coding and all, the operation team managing the entire cloud infra, you have to collaborate between all that. And I think that is the reason that the designing, the planning part has to be done by the cloud architects, the execution part has to be done by the DevOps engineers, and of course at the end the monitoring part has to be done by the operation manager, and they give big feedback to the DevOps engineer. They then their suggestion to the cloud architect, they design a solution like improve it, and DevOps engineer. This is a complete flow. You can see one person giving output to another thing, and one person giving input to another person, and that's how it works. So I think you can see that entire team when working on something that only can make this successful. So if someone want to start a migration project and have to want a success on it, they have to like work as a team to achieve that. That's very important.
That is the best answer I've heard in a long time. You just explained the whole teamwork and collaboration. So, what is one thing employers really care about when they hire people for these roles? Teamwork, because it's going to take a team of smart people. Great job, Sandeep, on that. Thank you so much. Okay, so Med, what can you do if there's no documentation or resources to use if you want to migrate an application? Do a simple lift and shift. The application is most likely running on a virtual machine. Make that virtual machine and machine image for the respective cloud provider, whether it be Azure, GCP on Compute Engine, or an AWS EC2 instance, and just move it directly to the cloud as is. We deal with this all the time. Organizations have applications that somebody coded, they either died or they no longer work there, and it's got to get moved, and nobody knows how it works, and there's no documentation. Take that server and literally just move it, lift and shift it, like we just did today, modify it in no way, and everything's going to work. And a lot of lift and shift applications, you can almost ignore the applications if you're just moving VMs. I'm not saying that's what you should do. I'm saying in this case, you're going to be good to go. Oh, Alonzo, how are you today? See, you're here. Mr. P, so happy to see you're here as well. Next question, Chris. Mr. P, Afri P, so happy to see you. When trying to visualize the concept of the design, what critical components that one should start visualizing? Okay, so great question. First place I start is I start with the customer and trying to figure out what is their business. If I don't know their business, I can't do anything. See, unlike me and unlike Sandeep, I know the kind of tech that's in Sandeep's house. I've got 9 24-core servers sitting in my house for fun, along with a 32-core workstation. Well, I needed that for streaming, but I like tech. But you got to remember, businesses do not. They don't want to spend any money on tech. All businesses want to do is make more money. So you have to visualize the customer's business first, Mr. P or Afri P. What is their business? How does the business work? What are the business challenges? What's going on with their financial statements? I start there. And then I start thinking about the current technology they have. Is it the right technology to get them to their goal? If it's not the right technology, what is the right technology? So I start with the baseline. I look at the business goals, and then I think about what changes I need to make to the organization's technology to improve them. And then after that, I'm doing it in modulars. So I might be thinking, okay, there's this new kind of application. We need that. This kind of server would do this. I literally look at it at the module level. What do we do? Okay, I need a load balancer. I need a load balancer. I need a server. I need a server. I need a router. I need a router. I literally look at them in generic terms. And then because I'm an architect, I go to the store. The cloud provider to me is a store. All I know is if I need a virtual machine, I go to the store and buy one. It doesn't matter to me if it's an EC2 instance, an Azure virtual machine, something from Google Compute Engine. The cloud's just a virtual data center. Who cares? So I'm going to pick one. If I need a load balancer, do I need a network one or an application one? I make the decision. And then guess what? I go to the store. It doesn't matter if it's an Azure load balancer, an AWS Elastic load balancer, any other load balancer for that matter. I'm buying a service that I need. So start with a goal. Then map the current technology, plan the future technology to help the organization grow, map it out in terms of all the tech components, and then translate those tech components to a cloud architecture on any cloud provider you want or multiple clouds. That's the process that I do. I use Mr. P, AfriP. How about you, Sandeep? Looks like you could be frozen. Okay, this is what happens with internet. It's best effort delivery, which is why you use direct connections when it matters most. So hopefully Sandeep rejoins us. Connectivity is always a challenge. So who's the next question from? How do you get hands-on experience about the on-prem ecosystem? Well, Akar, here's the best way I've been recommending it for years. Buy a 16-core server with a minimum of 128 gigs of RAM and 3 SSDs in a RAID 0 environment and or an NVMe drive. First, I want you to set up, and all my students do this as part of our Cloud Architect Career Development Program. And quite frankly, our students do this in our Rental Lab program as well. On this server, either buy one or use one of our programs. Chris can paste the link to these programs as well as a coupon code for you. But you could do it by buying your own server. First, set up server virtualization with VMware ESXi. Then go build some Docker containers. Then build an IP tables firewall to learn how firewalls work. Then build an OpenSSH VPN concentrator to learn how VPN concentrators work. Set up NFS sharing so you understand how servers and shared file storage works. When you're done setting up the file sharing, set up Windows file sharing, set up the Linux, Apache, MySQL, PHP stack, all of it. Do all these things. Then when you're done that, build an Active Directory server to learn IAM. And then when you're done these things, here's what I want you to do. I want you to build a cloud. I'm not joking. Build a cloud. Build a Nutanix cloud, build an OpenStack Ansible cloud, federate these clouds to your Microsoft AD. Now you're getting experience. The real things that we architects do is we take things from the data center to the cloud. You can't do that if you don't know the data center. So that's how you get hands-on experience. And while you're at it, you need some networking experience too. Guess what? Do the following. Get EVE-NG and practice some BGP, practice some real NAT, practice some routing protocols like OSPF and ERGRP. Set up QoS policies. Set up VLANs on some Cisco switches. Set up some VLAN trunks. Set up some .1Q tags. Set up some link aggregation groups or Ether channel things. Do all of it. Get great. And then you'll see this whole cloud is nothing. Every new service I'd look at, yeah, how that worked. I literally spent 2 days to pass a Google Professional Cloud Architect certification. Why was it only 2 days? Nothing's new in the cloud. It's the same things I've done in the network and data center for 20 plus years. So it's all these great things. So just understand this. Got lots of phenomenal opportunities, lots of great things that are actually coming, but just make sure you've got the right skills and you'll be able to do anything you want, anywhere, anytime. I don't know if I have time for any more questions. I know I do want to tell you this. We have right now, we just released it from my team, a new video on for people interested in getting the Price Tech jobs. This one is done only for freshers. The entry-level tech jobs have gone away. So our advice is on what to do instead. We released a video of the macro and microeconomic conditions changing the first level, entry-level jobs and what you want to do about it. Now, I'm also going to say that in a few minutes, here's what we actually have is as follows. At noon, we are going to have our How to Get Your First Cloud Architect Job webinar. On this webinar, we're going to do a lot of things. We're going to teach you how to leverage your past experience to get your future jobs. After we do that, We will tell you exactly what hiring managers want so you can get hired, because being what the hiring manager wants is key to getting hired. After we talk about what the hiring manager wants, we'll talk about what the actual job is. After we talk about what the actual job is, we'll talk about how to get competent at that job. And then we'll talk about how to get the extra skills necessary to get the job. We'll tell you how to skip HR and get your resume in the hands of the hiring manager, and so much more. So I hope I answered that question. It's been really a pleasure to spend the morning with you guys. I wish I had the opportunity to ask more questions, but my team has let me know that I just don't right now. If you have the ability to like this video, we like that. If you can comment what your actual career is, if you will comment what you want to be, cloud architect in the box versus cloud engineer in the box versus DevOps in the box, we'd love that. So thank you so much. Questions that we can't answer here, Chris is going to take down. We do the following. Every Wednesday, we try to have a free cloud computing career question and answer session. We answer your questions, but I'm also going to be making videos throughout the week that are common questions from LinkedIn and common questions from YouTube. So Chris from my team has taken down questions that we weren't able to answer, and we will answer them in a new live video or in a pre-recorded video coming very soon. Thank you so much for being here today. I got to say, Sandeep, my friend, thank you for being here. Sandeep, I'm always honored and privileged when you're here. Sandeep, you are a great resource to the community. You do a lot of free training. I do a lot of free training. Your quality is fantastic. So, Sandeep, thank you for being here. I will sync up with you later today. I'm really excited about our How to Get Your First DevOps Job program, working with you on that to really help people and all over the world get their first DevOps job, because I think it's a fantastic career. My world is architecture, because that's what I've done for the last almost 30 years. And as architects, I teach architects. We have some networking training coming out too, some extremely serious training. When we produce a course at Go Cloud Careers, we're not going to just take a bunch of certification tests and then test it and then teach it with no experience. We're making a cloud networking course. It'll be taught by two people at 3 CCIEs and 50 years experience between us. Everything we do is about your future. Everything we do is about making you great. I'm so honored and privileged to be part of this. Tyrone and others, thank you so much. Tyrone, we're going to make you an architect, and can't wait to do it. Jesse, always good to see you. Jesse is one of my prodigies, one of my students. What he's able to do in his youth makes me so happy. Chris, you love the code, VS Code. I think that's great. So I'm just happy to have all of you here. So, Homie, it's so nice to have you here as well. We got lots more coming out soon. Tyrone, wonderful. Thank you. I'm glad you got to see it in motion. That's why I want to do this. Alonzo, always thrilled to see you here. Somebody's going to be extremely lucky and steal you very soon. Afri P, oh my God, you got your server. Yeah, I'm so happy for you. That will change your life. Run a networking lab, run a cloud lab, run them all. This is great news. Fad, thank you so much. I'm a little bit more of a techie than I let on. Most of the time I behave like a CEO or an instructor of cloud computing and others, or a coach, because that's my job. And I'm still a techie at heart. Sandeep, welcome back.
Finally. So my internet got down and I tried to connect it via radio connection. So yeah.
So I'm not sure if you could pay attention to what was going on. I was thanking everyone. I was thanking you for the incredible job that you did. I was telling everyone how excited I was to be collaborating with you on how to get our first DevOps job program. And who knows, there's a couple of specialty DevOps careers out there too. You might see something based on more specialized careers coming soon. I'm honored anytime I can have my good friend Sandeep here. I love that we're collaborating across 2 continents. I love the free work that he does for the community. I think he and I provide more free training and have more content in our free training than everybody else's paid programs. And we collaborate as often as we can to do this, because we want to do the following. We want to know that our free that we give you guys is better than anybody else's paid. And when we give you a paid program, it will be 10 times better than anybody else's paid. So, Sandeep, do you have any last minute comments to close? I'm just honored you're here.
Thank you. So, Mike, I will say whoever want to do something, could be cloud architect related or DevOps related, but I will suggest that if you don't find any resources, make your own, because while I was working on initial phase, and I also didn't find many resources. Could be paid, but I didn't have the finance to go on. So what I did was I tried to look at very articles, because in most of this article, if you do find articles, look at the documentation, because 99.9 answers you can find the documentation itself. I found that. So when I started reading the white paper, started reading the the providers, like the platform documentation, it become a lot simpler. Try to do yourself, and utilize this kind of free content like Mike giving, I'm giving, utilize all that possible. And of course, we when you're coming with some premium content, of course that will be that level only. And do wait for what you're coming up, because you are creating some news program, and of course a special news program that Mike mentioned. That's, I think, slowly we'll be revealing in future.
We will be.
And yeah. And if anyone have any question, if you want to reach out to me, simply reach out to me via LinkedIn, or if you want to watch some or want to watch some those tutorials in my channel, just search by Sandeep Das, you'll find it. And if you want any cloud architect related content, AWS or network related content, Mike has awesome content. Do go to Mike's video section, YouTube channel video section, and search by the content that you are looking for. You'll find it there. So use this kind of resources as much as you can. That's it.
And I feel the same way for DevOps researchers. Go to Sandeep's page. I'm telling you, his free is better than anybody else's paid. So, and I 100% agree with him. See, I was actually asked to teach someone how to become a cloud architect. And, I've been doing this forever. So I said, well, I don't have a lot of time. Little do I know. I said, I'm going to buy you the 3 best-selling courses. So I bought him all the 3 best-selling courses. Pretty much 2 of the 3 people worked at the same company at one point. The other one I won't even mention. When I actually looked at the courses 3 days later, the kid says to me, he says, Mike, I set up an EC2 instance and configured an S3 bucket. What are they? And I said, what are you talking about? And I watched these videos. And literally speaking, it was the name of the service and how to configure it. And I basically said, no one's going to get a job after watching this. So we created our own documentation. We wrote that Certified Solution Architect Professional book, and we stripped 10 pages out, and it's completely free. You can have that free book on passing the Certified Solution Architect. The link is in the description below. We have a completely free AWS Certified Solution Architect Associate course. The link is in the description below. We have a completely free AWS Certified Solution Architect Professional course. The link is in the description below. We have a completely free AWS Advanced Networking course. The link is in the description below. And I may do a little CCNA class coming soon. We're contemplating it to give people some networking background. So, like Sandeep said, make your own documentation. Make your own cookbook. Make it so that you know it. Work within your strategy. Be great. Love what you do. And watch all the great things that are happening. Sandeep, I'm super excited to have you here again.
Same here, Mike. Always love to communication and share the knowledge as possible.
Well,
awesome.
I want to do another one real soon. You add so much to my audience, and I hope I can contribute to your audience in the terms of architecture.
Definitely, Mike.
So I will give you a call very soon. I'm very grateful for your help, and thanks so much.
Thank you, Mike.
Take care. Have a wonderful day. Bye, everyone.
Bye, everyone. And see you soon in the next session.
See you very soon. Take care.